What is a digital factory?
So digital factory, there are, I mentioned earlier, depending on who you ask and which industry you ask, you're going to hear a lot of different answers and a lot of different, ideas about digital factory. So, digital transformation exists in every sector, every industry. Whether it's retail or manufacturing, it means different things to different industries. So in manufacturing, that's my, I have years of experience, almost 30 years of experience there. On one extreme, lights out manufacturing. What does that mean? It means physically the plant is completely automated. Raw material is loaded on one side of the dock, comes from our trucks and whatnot, and the finished product comes out on the other end. You don't even need any lights, meaning you don't have anyone in the plant, physical human beings there uh, doing the manufacturing. It's completely automated, robots and material handling equipment and equipment running. And there are factories like that. The famous example I've heard about, I've never seen it, is a Fanuc robot making plant somewhere in Japan. One of the sales engineers, they always invited, hey, if you want to go see, or if you're in Japan, you can go see. That's the extreme end of it. Oftentimes what you see is, um, some form of physical automation, and off late, a lot of digital automation. Um, you know, you know, Manufacturing generates ton of information. The data is collected and stored locally, or sometimes fed into corporate servers. Most of the data, almost 80-90% of the data that it goes unused. The data never gets translated into actionable information.
So
To me,
what kind of data gets stored in corporate servers in manufacturing?
Um, every millisecond, there's something collected. Yeah, if an operator pushes a button, if a temperature changes, if a robot moves, everything is observed and collected as data and gets stored. And it could be equipment status data, how equipment is working, or a product related data, like at what temperature a product was made, or at what speed was it made, things like that. So anything you can see, observe, it is getting collected and stored. And most of the time, it gets stored and it's sitting there, not being used. Often when
So my
there's
first, my question is, how is it collected?
so you know on a modern digital factory, you have sensors of all these, how it is collected and everything is defined by a standard called ISA 95. It was developed way 30, 40 years ago at the Purdue University. It used to be called Purdue model. And it describes how different systems and different levels of systems classified and how they talk to each other. And from all the way from the shop floor, the sensors like a temperature sensor or a speed sensor or anything, all the way to the corporate systems like the enterprise resource planning, ERP systems, product lifecycle management systems, customer CRM tools. The ISA 95 model describes that.
Mhm.
And so at the shop floor level, at level 0, level 1, you have sensors, you have programmable logic controllers talking to the sensors, and the programmable logic controllers in turn are talking to SCADA systems or MES tools. SCADA is a supervisory control and the data acquisition systems. These are all more of a software systems.
Mhm.
So the lowest level, the data is collected at milliseconds and microseconds. As you go up, the data gets consolidated at the PLC, still milliseconds. At the MES or SCADA systems, maybe seconds, minutes. As you go into ERP, it's more of days and weeks, and that's how its data gets collected,
Okay.
gets filtered. For a ERP system, they don't really need to know how fast a product ran. Rather, they want to know when the product will be done, production will be ready to be shipped out, so they can give that information to their customers. So that's
Okay.
how the systems work. Yeah.
Okay.
So if you carefully observe what Sridhar talks about, he says that in most companies, and especially in manufacturing, which is the example that he talks about, there's a lot of data that often gets collected but often not used. I think this is something that all of us need to think, saying, hey, is data available? Of course, data is available. Is it being used? Most often, it's not being used. That's one part of the problem that I think, you need to think. The other important point that, I see here in this point that he makes is that if you look at, industrial transformation, you did physical goods. The physical goods were not automated. Then you started looking at, hey, how do I do a lights out manufacturing process where there is no hands touching right from the time when, the products, the raw materials come from the stockyard to actually becoming a finished good. So that's really how physical factories really started changing. And then you started saying, how do you really do a lights out manufacturing process? Now, that is probably exactly what's happening to knowledge factories, where you had physical people, you are doing the programming, you are now doing the programming, you get a lot of business problem, and then you start looking at saying, hey, how do I really automate the process? So, there is a requirement that's coming, there's a solution that needs to be built, there is a software that needs to be done. So now you have the AI and the machine learning really looking at saying, okay, how do I solve this problem? So the fundamentals of how from an industrial economy to a knowledge economy, the change happened over the last 50 years. The tenets of how do you build a digital factory for a knowledge industry pretty much can be learned from the manufacturing industry, and how the transition from industrial economy to a knowledge economy happened, and therefore how digital factories were built in the manufacturing sector. And that's really how I think the knowledge factories of today will become digital factories of tomorrow.